going to cover a few theorems and one corollary and some more definitions. So starting with theorem 9.1. 9.1. If a line is tangent to a circle, then the line is perpendicular to the radius drawn to the point of tangency. So we need a circle. And then we're going to need a line that's drawn perpendicular, or rather tangent to the circle. The point of tangency is the point that that line and the circle share. It's the point where the line is tangent to the circle. Finding the center of the circle so we can draw a radius. What we want to show is that when we draw that radius, we must be drawing a line that's perpendicular to the tangent. We'll call this circle O, point of tangency T. We'll look at a point S here. So our given information is that ST is tangent to circle O. It doesn't look like my O is in the center when I'm standing in front of it. Let me try to find a center. I don't know that that's a lot better, but I think it is a little better. Okay. My given information is that line ST is tangent to circle O at T. Remember, a circle can be written as a circle rather than the word circle. Okay. I know. We were both happy to. Okay. What we want to prove here is that OT is perpendicular to line ST. We're going to do this with an indirect proof. So tell me, how are we going to? Yes, sigma OT is perpendicular to line ST. Yes. So if we want to do an indirect proof here, how do we start it? What are the keywords to an indirect proof? Wait. Assume temporarily, yes.
Assume temporarily.
We assume temporarily what?
T is congruent to TO.
No, the opposite of what you want to prove. You assume temporarily that OT is not perpendicular to ST. Okay? So assume temporarily
that ST is not perpendicular to OT.
And the way you would do not perpendicular is you would do a perpendicular symbol with a not slash through it. Okay? So it is not perpendicular to S. I should say OT. Here I was thinking about too many things at one time and made a grave error. Okay? Thank you. Not perpendicular to line ST.
You took my pencil.
Why did you do that, Dustin? Now, if OT is not perpendicular to ST, then there must be a line that is perpendicular to ST. So let's say then that means that there is a line OP. OP is perpendicular to ST. Now if you think that looks funny, it's because it's impossible, right? So we're going to assume that for the argument's sake. Okay? This means that there must be a line OP that is perpendicular to ST. Because through any point off a line, there is a line perpendicular to the line through that point. So there has to be a line through O perpendicular to line ST. We're going to call the place where it intersects the STP. So call the point that intersects STP. Stop it. Okay. Now, we have a theorem about a segment that's perpendicular. It must be the shortest segment that can be drawn from a point to a line. A perpendicular segment must be the shortest segment that can be drawn from a point to a line. I want you paying attention. So that means put the little pieces of paper away and write in your notes. You don't have a pencil in your hand. That looks better. Now the little pieces of paper need to disappear. Thank you. Hannah. Yeah. Thank you. Okay. Oh, yeah. Since a perpendicular segment is the shortest segment that can be drawn from a point to a line, OP must be shorter than OT. We should be running into a problem when I say that. Bar, you need to quit your thumping, and Branson. So since a perpendicular segment is the shortest segment that can be drawn from a point to a line, OP is less than OT. Can OP be less than OT? Why not? Because it goes outside the circle, right? So OP is the length of the radius plus a little more, isn't it? Since, and I'm going to say that, since OP is the length of the radius plus a little more, OP is greater than OT. You have a contradiction. What do you do once you arrive at a contradiction in indirect proof? What do you do?
What do you do?
You have to say, well, this is not true. 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 This is not true what do you do once you arrive at a contradiction in indirect proof?
This means the opposite is true.
Yes, you say, this means our assumption is wrong, and instead the opposite is true. And then we're almost done here. So here's where we say, and Dustin, you're talking to Branson. Branson, you're talking to Dustin. That means you're not paying attention.
Sorry.
Okay? So now, this is a contradiction. So what we assumed must be incorrect. I thought you were taking notes there.
I don't recognize that.
Well, then pay attention to them.
I was thinking of a numbers. That's not paying attention.
Okay, must be incorrect and instead the opposite true. And the opposite, the OT not perpendicular to ST would be, so OT is perpendicular to ST. All right, we have a corollary to this now. We know now that, like we thought in the assignment on that problem, we know now that if you draw a radius to a point of tangency, then measure of angle OTS must be 90. We just proved that. So now, let's look at the corollary to this. Corollary 1, tangents to a circle from a point are congruent. I'm writing a corollary. Pay attention.
I know what it says. Tangents to a circle from a point of the circle. No, it's not. Yeah.
Uh-huh. Yes. All right. What this means is we have a circle and we have a point. We have tangents drawn from that point to that circle. How many tangents can be drawn from that point to the circle?
A circle like this too.
How many tangents? One of them that goes and touches the circle above, right? And, let's move that up a little bit. One of them that goes and touches a circle below.
So the tangent to a circle required.
Now, what does it mean by the tangent then? Well, it's talking about the length from the point of tangency to this point right here, and the length from that point of tangency to that point right there. That's what it's talking about by the length of the tangents. So we have a tangent, a point of tangency T and a point of tangency S. Our given information is that line TP and line SP are tangent to circle, and we need to find a center here. We'll call it circle O. what we want to prove then is that the length of TP is equal to the length of SP, or that those tangents are congruent. In order to prove this, I'm going to draw my radii to the point of tangency. What do I know happens by the theorem 9.1 when we draw a radius to a point of
Line is tangent to a
tangency?
circle, and the line is perpendicular to the radius drawn to the point.
Okay, so what do we know here in this diagram?
That O is perpendicular.
What's perpendicular? You see why you need to pay attention besides just write down the theorem?
Line OT.
Yes,
OX is perpendicular.
OT is perpendicular to TP and
Yes.
OS is perpendicular to PS. Thank you. Now, when I draw from O to P, I am forming two triangles. Are these two triangles going to be congruent is the question. They share a side OP. What else is the same in both triangles? The radii are the same and the angles are the same. So now we have side, 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 side angle, side angle, side angle, 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 side, and hypotenuse leg. The hypotenuse leg theorem, yes. They share the same hypotenuse and their leg is congruent. So these triangles, triangle TOP and triangle SOP, are going to be congruent by hypotenuse leg. Does this mean that TP has to equal SP? Why? When the triangles are congruent, all their corresponding parts are congruent. So, because CP, CTC, corresponding parts, congruent triangles are congruent, TP will have to be congruent to SP. And that is the end of the proof of this corollary. Theorem 9.2 now. If a line in the plane of a circle is perpendicular to a radius at its outer endpoint, then the line is tangent to the circle. What's that? It's page 333. So what we're going to need here is a radius. So I need to find a center. Does it look like I located the center all right? Because I'm off center when I do it.
No, it needs to go down.
Okay. Is that better?
Yes.
A little more?
Right a little bit.
No, it's good.
Is that pretty good?
Yeah, that's good, that's pretty good.
Okay. So we'll call that O again. Generally, when you have a center in a circle, very commonly you call it O. You can call it anything, but
other side.
very commonly called an O. So we have two eyeballs.
It looks like
Yeah.
you said, you guys will have.
Okay. Now, what we want then is a radius.
Oh, yeah, it's fine.
And we want a line that's perpendicular to the radius at its outer endpoint. So, we want a line that is perpendicular to the radius there at its outer endpoint, which means, let me be perpendicular and then I can shift it. Now I know I'm not centered here, so of course I don't draw things exactly right. But does that kind of look like it's perpendicular to the radius at its outer endpoint? Okay. Ah, maybe I got it. Okay. So now, we're going to have to call that point T, very common to call a point of tangent CT, and we'll call this point S just so we can name the line. And what our given information is a line in the plane of the circle is perpendicular to the radius at its outer endpoint. So we are going to be given that line ST is perpendicular to segment OT. What we want to prove then is that the line is tangent to the circle. So we want to prove that ST is tangent to circle O. What does it mean for it to be tangent? What does it
Intersects
mean?
a circle.
In how many points?
1 point.
In exactly 1 point. Now, if we were to prove this with an indirect proof, what would our first sentence be?
Temporary.
Right.
Assume temporary.
Assume what?
Temporarily. That ST is not
No?
tangent to.
Yes. The opposite of what you want to prove, that ST is not tangent to circle O. So now, we might be able to get through this proof here. We are not going to have an assignment, but I want your attention, okay? So now, we're going to assume temporarily that ST is not tangent to circle O.
That's circle. Converse. That's converse.
Now, if ST is not tangent to circle O, but does intersect circle O at T, then it must intersect circle O at another point.
What's the
So if I think of ST as somehow being bent, so it goes through T and it intersects at 2 locations. Since this is something that really cannot be true, we're going to end up with a contradiction and our diagram doesn't look quite right. Right? But this is point S right there, we'll say. Now I know that OT is perpendicular to ST, that's given. So this is a 90-degree angle. If I draw a segment from O to S, I have an isosceles triangle. What do you know about the base angles of an isosceles triangle? They're equal. So since angle OTS is 90, then angle OST will have to be 92. Is there a problem with a triangle having 2 90-degree angles? Yes. Okay. So because triangle OST is isosceles, triangle OST must have two 90-degree angles,
Which, how do you tell it?
which is impossible, exactly. This is impossible, so what we assumed must be incorrect.
Which means, intersection between center.
So the opposite must be true, which is ST is tangent to circle O. End of proof.